right, today, really, it can be pretty easy to understand. I have faith in you, I do. So, 12, 13, diciembre, 13. So objective, really talk about sum to infinity. Okay? Now if it's a sequence, one more time, a sequence is just a list of numbers. We're not adding them. A sequence is just a list of numbers, okay? Okay, if it's geometric, then it's going to be multiplying by the same number. And we call that number R, whatever the ratio is. That's our R, right? Divergent conversion, okay? Watch. Divergence. Divergent is a word that means simply this. It's divergent, it's going to go off. Okay? So it's either, like loop, right? So divergent is either going to go to infinity or negative. Okay? If it's divergent, it's going to go either off to infinity or negative. Convergent means it's converged to something, right? So let's write that down. Divergent means it's going to go to infinity or negative infinity, okay? So if it's divergent, it's going to be a sequence that approaches infinity or negative infinity, okay? So it's either going to go to infinity or negative infinity, okay? So if I take a look at this first example, 1, 2, 4, 8, 12. It's going to infinity, isn't it? It's getting bigger and bigger and bigger. This one's going to be divergent, right? Convergent means it's going to go to a specific number. So it's a sequence. It's a sequence that approaches a specific number. Like the second example. And I'm going to write this down in a second. I'll let you get caught up. But 0.9, 0.99, 0.999, 0.99999. What's it getting closer and closer to? 1. So this one's going to be converging to 1. This one's going divergent because it's going up to infinity. Does that make sense? See how it works? So it's not hard. This one then is divergent because it approaches infinity. And this one's convergent because it approaches 1. So if it approaches a specific number, okay? Now, the third one's a trick question, but you guys won't get tricked, okay? We agree, it goes up to infinity. This one's going closer to 1.9, 0.9999, right? This one's a trick question. You would think that it's going to 0, wouldn't you? It keeps going, right? Minus 10, minus 10, minus 10, minus 10, minus 10. So then you get negative 10, negative 20, negative 30, negative 40, negative 50. This one's divergent, isn't it? It's going up to negative, see? So this one's definitely divergent because it is going to negative infinity. So if I go ahead and just keep it going, I have like 10, thanks Kestrel, 0, negative 10, negative 20, negative 30, dot, dot, dot. This one's divergent. It's approaching negative infinity. Okay, thumbs up so far? Okay, good. All right, example 2. So this is going to be 10 plus 1 is 11. 11.1, right? 11.11 right? 11.111, right? Yeah, so let's use our formula, because I'm not sure what the answer is. But if we use our formula, we can find out what happens. Okay, no, it's going to be 11 something, right? R is our multiplier, so great question. So I want to help you with the R. So we're going to use S of infinity, okay, equals A1 over 1 minus R. So Alonzo, you asked a really good question. So please have this somewhere, that R can always be found by the second one divided by the first one, okay? Always. So let's see here. This is my first term, my second term. So my R is going to be 1 divided by 10, or 1/10, which is the same thing as, yeah, 0.1, exactly, right? So I can use my formula to get the answer. I think it's 11. It's 11 point something. Do you guys agree? So let's use our formula. So we're going to go A1, 1 minus 0.1, okay? Let's see what it's getting. Yeah, I know it's going to be 11 point something or other, so let's see. I'm going to go ahead and go 10 divided by parentheses 1 minus 0.1. 11.1111, right? Okay. Okay. Now, repeating decimals are the same thing as to infinity, okay? In fact, it turns out that, I'll just tell you, that ask about leaving early, while you're down there. So it turns out that this 0.11111 is 1/9, okay? So repeating decimals can also be fractions. We know like 1/3, 0.333333, right? We know 0.6666666, 2/3, right? So 0.45 is also a fraction. Okay, so I'll show you. It's actually really easy. All right, so 0.45 is the same thing as 0.45454545454545 dot dot dot. Got the idea? Right? You guys got the idea? Right? So it does repeat. So I'm going to use, it goes on forever, so I'm going to use my S of infinity problem, okay, A1 over 1 minus R, to find out what that fraction is. I want to use my formula. Okay, I like this formula. So what's my first term? Well, let me rewrite it. 0.45 plus 0.0045 plus 0.000045 plus dot 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 dot. Okay? Right, so what I did is, I wanted to look like what we've been doing up here, okay? I wanted to look like that, so 0.45, 0.045, because that goes inside of there, right? Plus a 0.0045, because that goes in there. And basically, this decimal can be made up like this, right? So, are you okay? 0.45, 0.045. This sum is this decimal. Does that make sense how it fit? This would fit right in there, that would fit right in there, so forth and so on, okay? Can you see it? So, A1, that's 0.45, right? What's my multiplier? How am I getting from here to here to here to here? How am I getting there? Take this one divided by this one. So to find my multiplier, Alonzo's working on it. R is equal to my A2 divided by A1, and I think you get 0.01. So I got R is 0.01, okay? All right, now I can use my formula. I've got my first term. Let me highlight that. There's my first term. There's my R. S of infinity then is equal to 0.45, 1 minus 0.01, which is 0.45 over 0.99. Hold on, 0.99, right? 1 minus that. You okay at 0.99?
1 minus 0.01 is 0.99, which same thing as 45/99. And that's it. This fraction is this decimal. Let me check it out, make sure, okay? Hold on. 45/99. Hey, same problem, right? So every repeating decimal is a fraction. Every repeating decimal is a fraction, okay? All right, let's turn the page. We're getting there, okay? All right. So example 3. Is it getting smaller?
It's getting closer to 1.
Is it getting smaller though?
Yeah.
Okay, so I know if it's getting smaller, I can use that form, right? It's got the dot, 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 right? Hard part is, what's the multiplier? I'm not sure. I'm not sure what the multiplier is. Well, let's see. I want to use my S of infinity. I want to use that formula, but I don't know what R is. But R is A2 divided by A1. If I can't figure it out, I'm just going to take -4 over -6, which is 2/3. So what I'm doing is taking 2/3 of something, right? 2/3 of something, 2/3 of something, 2/3. Isn't it getting smaller?
Yeah.
2/3. So my very last piece, if I can get to infinity, be like nothing, right? So I'm going to use this formula. There's my first term. There's my multiplier. Let's get an answer. Okay?
2/3, good.
Okay. So we're going to go S of infinity. Whoop. It's going to be A1, which is -6 over 1 minus 2/3. All right, well, I know how to do fractions. This doesn't bother me. That's the same thing as -6 over 1/3, which is going to be -18. All right, let's see if that makes sense. Let's see if that makes sense, okay? Yes, what I got. So, okay, ready? I got -10 here. Then I got another -2, that's -12 1/3. So -10, -12 1/3. It just gets a little bit bigger at a time. That's what it would all those add together, all the pieces, okay? All right, now, almost done, almost done. So if I take a look at example 4. Oh, it's easy. This one's easy. So first of all, we're going to what? We're going to what? And it's a sum. It's a sum to infinity, right?
Yeah.
Should we use that?
No, yeah.
Yeah, what's our multiplier? Can you see what's our multiplier?
1/3.
It is 1/3. Is that less than 1?
Yeah.
So we just have to take this formula. What's our first term? You know what our first term is. 4 goes there, right? What's our multiplier?
1/3.
It's easy.
Very.
Yeah, so just do it. Let's put it in front of us. So S of infinity. S of infinity equals
Follow your finger, bro.
A1 on this one here. Oh, it's just, oh, they're right there. That's all the way from the summer. Doing wood. The wood pile.
Okay.
You ever smash your finger with when doing wood?
No, the left one. Hey, I got 6.
The left one, that's just ink. That's just ink.
Hey, what's under your thumb, though?
What's under my thumb? What do you mean what's under my thumb?
That thumb right there.
This one?
Yeah.
It's just blood.
Oh, it's just blood. Don't worry about it. It's just blood. Yeah, but I know how good, but I got you getting out my finger. So, wait, what did you do to your thumb? How did you get that far back?
Oh my goodness gracious. One more time. So this summer, and I'm sure.
Summer? It's all the way back to
Yeah.
summer.
Yeah, it's always back to take that long to grow back,
I
right?
cried.
No, I mean, think of it. I'm assuming some of you have worked with logs. I mean, Ray and I think maybe, right? And you're throwing logs. You got some big logs, but you're a big guy. You can throw big logs, and some other big guy throws a big log on your thumb, and it hurts. Right?
Not big guy no more.
So way back in like, I think maybe September, I was doing my wood pile and Keegan, not that she's a big guy, she's helped me out, she threw the log on her finger and it hurt. So anyway, fingernail came off and slowly been growing. Can I get back to this?
Oh no, man, that's not freaking me out.
I'm done.
You kind of lost it.
All right.
No, I got it.
So, when you take medicine and you have to take it every day, right? And you take it every day for like 2 weeks, it's the same kind of thing as an infinity product. The doctor wants, it will actually be higher than 400 milligrams in your blood. I'll show you why. It's higher than 400 because your first dose is 400. And then a day later, you still got some in your blood system. You take another dose of 400, right?
Then it's like 500.
Now, 2 days later, you still got some in your system from the first day and the second day. And you take another 400. See how it builds up? And the fourth day,
You're gonna overdose.
no. See, the fourth day, the first dose is pretty small, but you still got stuff from the first day in your system, second day, third day, then take another day's dose. So it comes up and it levels up to a higher dose. That makes sense?
Yes.
So when they say take the entire thing, they mean take the whole thing, because if you take a couple of days off, then it drops, right? The doctors want it to level off at a certain level. So this is that kind of problem. Now, even though we're not going to take it to infinity, the piece becomes small enough that we just consider it an infinity problem, okay? So let's find out what it levels off to. So
If we go S of infinity, right? A1, 1 minus R. We know the first dose is 400. So it's going to decay at a rate of 80% every day, right? So you're going to lose 80%. So 20% or 0.20, right? And if I use my calculator, it really levels off to 500 in your bloodstream. So the doctor's goal is this. The doctor's goal
is to get it up to 500 milligrams at a steady rate in your body, because that's the dose that'll fight the disease or bacteria or whatever.
That actually how that works.
That is actually how it works. Yeah.
Cool.
Yeah. And the doctors have charts. They don't actually do the math. They have charts. They look at your weight and your height. And some smart mathematician like us have already done the math for the doctors. They just look at the chart and they do it. But it's that formula. See, pretty easy, isn't it?
okay, we are done. So page 213, 1 through 8, it's not that many.